All right, we're now recording. We actually have a short week this week. We have no classes on Thursday. So Thursday's a one-day weekend, sometimes I like to call it. Okay, so our modified calendar. Okay, so no classes at all Thursday, not just my class. If you have any other CSM classes, it's a flex day, which means teachers have to work and show up and stuff like that, but you don't. Okay, and again, I'm swapping the two dates here. Okay, so the exam is going to be Friday the 30th, and instead we'll have a quiz on the 23rd. Okay. Yes, last Friday's quiz was a lot more demanding, and I realized most of you weren't finished in time, so I let you have the rest of the day to try to finish it up. It was definitely a harder question. It's not likely I'll ask you that kind of question in its entirety on the exam because it just takes too long. Okay, so if I have you do one of those kind of problems on the actual exam, it'll either be easy enough that you can finish it rapidly, or I'll just have you do a subset of it. I'll just say, okay, just do the first derivative test, or give me domain, intercept, symmetry, or only do the second derivative test, blah, 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 blah. I realize you only have an hour, and I'll try to construct the test accordingly. Okay, and so Monday, Tuesday, Wednesday, no class Thursday, my class or any other CSM class. So Friday, I'll give you another quiz. We're not going to have the exam. It'll be on the 30th now. But that doesn't mean I'm going to stop. I will very likely keep according to schedule here and go on to 4.9, 5.1, and so on, even though this material won't be until our last exam. So coverage for the exam will stay the same, 4.1 to 4.8. And even though I'm going to keep going on 4.9, 5.1, that will not be on the test. To be honest with you, if we did not have that Thursday flex day this week, which I'm not disagreeing, I'm sure if you don't mind having a day off, and I don't either, but if we didn't have that day off, I probably would have been able to keep the schedule. Say in other semesters, when I got to this point in the semester, I would have just kept the exam here, but because I lost that day there, I feel like it might be a little bit rushed to get everything in. I'm still aiming to get just about everything in, but I felt like, okay, it's a little bit rushed, so swap these 2 days, okay, and we'll just go from there, okay. I gave on Canvas announcements, I gave you the solution to the problem on Friday, right? F of x equals x e to the negative x. Okay, and most likely Friday, I'll give you for the quiz one of those word problems. Okay, one of those applied max-min problems where you have to help each other out. And I agree, those can also get long. I realize that. So it might be another kind of thing where, you know, I'll give you most of the class period to see if you can figure it out on your own. Okay, so that's where we're headed at the moment. So I'm going to go back and do some more of the applied max-min problems 4.7. I'm not sure I'm going to start 4.8. I don't have to, as you can see according to schedule. I'm going to be okay if I don't. I may decide to go back and do some problems in a previous section, especially a curve sketch, since some people had asked for that too. Okay, so that's what we're up against. Let me check the chat. Okay, so yeah, see, some of you came late. Anybody who comes late, you know the way it works. Just put your name in the chat and I'll get you later. And by the way, if you join late and you don't put your name in the chat, I never look at it. I never know that you joined necessarily. It's not like we're meeting in person where if you walk through the door, I can tell that you're coming in, right? Now I can't tell if you joined. So the only way I'll know is if you put your name in the chat that you say, okay, I came a little bit late, then I'll get you a little bit later, okay? So please make sure you do that at any given time. Okay, so I'm gonna do some more of the word problems, applied max and min. How do you maximize the quantity? How do you minimize the quantity, right? And I gotta hold off on 4.8. The only thing I'll say about 4.8 is it's very calculator dependent. If you have a button that has an answer key, ANS, okay? If you have a button that has that, it's going to be much to your advantage if you have that key compared to those of you who don't have it, okay? Now, if you just have a regular scientific calculator that doesn't have that answer key, ANS, like this, it's going to be a little bit harder for you to do the homework and any quiz and test. It doesn't mean you can't do it, it's just going to be longer, okay? It would really be appreciated if you had that answer. But now, if you don't have that answer button, that's okay. You're still going to be able to do the exam. It's just going to take you a few minutes longer. and it'll be a little bit more tedious. Okay, in fact, I will grade your exams and I'll try to make the questions in 4.8, assuming you don't have the answer button. But if you do have it, it just makes it much more clean. Okay, so the question is, do you have a calculator that has this ANS button, which stores the last result? Okay, so for instance, if I just, I don't know, do something real easy here, 3. Okay, so I type 3 plus 4, and then I see 7. That's now stored in the answer button. So if I hit second answer, it shows 7. Okay, so pretend I go 49 divided by second function answer. The calculator or computer knows that's the same thing as if I type 49 divided by 7. And it comes back with a 7, of course. Okay, but we'll get to that in time. Okay, so I'm going to keep going, doing some more of the word problems for the majority of today. All right. All right, so here we go. Problem number 21 from 4.7. Find a point on the line y equals 2x plus 3 that is closest to the origin. Find the point that's closest to the origin. Now, you can actually do this without calculus, but this is a calculus class. So if I ask you that kind of question, you're expected to show it to me in the way that we did it in class, in a calculus format. All right, here's the picture. Y equals 2x plus 3. We know it's a line. Slope of 2, y-intercept of 3. Here's the origin. Okay, so out of all the infinitely many points on the line, which one's the closest, right? So do I go that way or that way or that way, right? Now, just eyeballing it, it looks like it'd be a point over here somewhere, right? Maybe it's in the second quadrant. So how do I find where that is? Okay, I got a little picture here. Here's delta x, here's delta y. This is the hypotenuse. Okay, so by using the distance formula, the square of the distance, a squared plus b squared equals c squared, is delta x squared plus delta y squared, right? x2 minus x1 squared plus y2 minus y1 squared is equal to the square of the distance. Okay, so distance squared equals x squared plus y squared in this picture. Okay, x1 is 0, y1 is 0. Okay. This is the point x comma y. So the distance from xy to 0, 0, okay, or the distance squared, I should say, is x squared plus y squared. Okay, but what is y? Y is given to be 2x plus 3. Right. See, the idea behind a lot of these problems is to get it down to a single variable. I don't want multiple variables. I just want a single variable. So it's x squared plus y squared, 2x plus 3 squared. So that's my f of x. And that's a quantity that I want to minimize. Okay, so one more time. I use the distance formula. It's a Pythagorean theorem, a squared plus b squared equals c squared. So here's a point x comma y. Maybe I should write that down for you as x comma y. So I'm going from xy to 0, 0. It's x minus 0 squared plus y minus 0 squared, x squared plus y squared. But what's y? Y is 2x plus 3. All right, so that's what I'm trying to minimize. Okay, and by the way, in this instance, this word problem, we do not have any limitations on x and y. A lot of the other word problems, we said, oh, x had to be positive or y had to be positive. That's not true here. In fact, looking at the picture, it seems like x should be negative, right? So we allow for negative quantities. So eyeballing it looks like x should be negative and y should be positive. Okay, so you could square this. I didn't feel like it, so I just left it like that, take the derivative as it stands. All right, so f prime of x is 2x plus 2 times 2x plus 3 to the first power times 2 by the chain rule. So 2 times 2 is 4, so 2x plus 4 times 2x plus 3. Simplifying, that's 2x plus 6x is 10x, plus 4 times 3 is 12. That's my first derivative. Okay, second derivative, 10. 10 is greater than 0. Second derivative greater than 0 means concave up, means minimum. Am I looking for a minimum? Yes, I am. And again, the book won't trick you, and I won't trick you either. If it's supposed to be a minimum, it'll come out to be a minimum. And if it's supposed to be a maximum, it'll come out to be a maximum. You don't have to worry about, is it going to come out the wrong way? But you do need the second derivative test in general for these kind of problems in order to prove a maximum or minimum. All right, so I set the first derivative equal to 0, and then I'm pretty much home free. So my first derivative was 10x plus 12. Set that equal to 0. Simple algebra, subtract 12, divide 10. X is negative 12 over 10, or negative 6/5. So that's my x coordinate, which is negative, just as I anticipated. Okay, and now find the y coordinate. How do I find the y coordinate? Plug back into the original, which was 2x plus 3. So y is 2 times x, which is negative 6/5, plus 3. Common denominator is 5, so times 5 times 5. So negative 12/5 plus 15/5 is 3/5. Right, so my ordered pair is negative 6/5, 3/5. And that's my final answer. Okay, so that one point on the graph, negative 6/5, 3/5, that is the one point on the graph where I should minimize the distance from the origin to a point on the line. So that's what's happening there. I don't know, some practicality, suppose you're in the water here. This is all water. This is this seashore. Okay, so which is the shortest direction I should go to minimize the distance to get back to land? And then you should head in this direction, obviously, right? Okay, so that's it for that one. I don't have to show you all the other stuff because all the other stuff on this page I've already shown you before. So let me just do my focusing thing for this one before moving on to the next problem. Okay. All right, so let's see, I already showed you that. Okay, so we'll put this away. Next one I'm going to show you. 4.7, number 11. Okay, now, we're not going to worry about A, B, C, D, E, F. Okay, we're just going to answer the question. Considering the following problem, a farmer with 750 feet of fencing wants to enclose a rectangular area and then divide into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? Okay, so the problem really stops right here. Okay. Now, if you've already done the problem and you did A, B, C, D, E, F, or whatever, that's great. Okay, but I'm just going to go straight to answering the question. Okay, so here's the picture. I made it look like this. Okay, so there's 4 pens like this. I call this X, I call this Y. So the area is X times Y. All right, now it says fencing, we have 750 feet available. So that, and these two add up to 750. Okay, so the way I got it labeled, I have 1, 2, 3, 4, 5X and 2 Ys, right? 5X plus 2Y, and that is equal to 750. That's all the fencing that I have, right? I'm constrained. My constraint is I can only have 750 feet of fencing. How do I arrange it so I maximize the area? Right, so our usual protocol is to try to solve for the variable which isn't X. So solve for Y, that's easy. Subtract 5X, divide by 2. So Y is equal to 750 minus 5X divided by 2. Actually do the division. 375 minus 5/2 X. So I pick that up and plug it right into here. So that way I only have one variable, X. So A of X is X, Y, and here's Y, 375 minus 5/2 X. Distribute 375X minus 5/2 X squared. And that's what I'm trying to maximize that quantity. I want to maximize my area, which makes sense. Okay, a farmer how do I get the maximum area, right, for my animals or my plants or whatever. And yes, for this kind of a word problem, do you think we want positive quantities? Sure, we don't want any negatives. Doesn't make sense for x to be negative or y to be negative. So if I get any negative answer, throw it out. All right, so first derivative is 375 minus 5x. Second derivative is negative 5. That's less than 0. That means concave down. That means I have a maximum. Am I looking for a maximum? Yes. So if you do the problem right, it'll always turn out the way that you want it to be. If it's supposed to be a maximum, it comes out to be a maximum. If it's supposed to be a minimum, it comes out to be a minimum. All right, so all we have to do now is set the first derivative equal to 0, solve, and there we go. So set a prime equal to 0. 375 minus 5x is 0. A little bit of simple algebra, move over the 5x and divide. X is 75. So x should be 75 feet. Then I figure out the y. I have a formula for y, 750 minus 5x divided by 2. So 750 minus 5 times 75 divided by 2, that comes out to be 187.5. Right, so the dimensions I'm supposed to have are 75 feet by 187.5 feet. Okay, so to maximize the area, 75, 75, 75, 75, 75, and 187.5 here, 187.5 here. Okay, I'm not quite done. I have to find the area itself because answer the question for number 11. What is the largest possible total area of the 4 pins just above letter A? What is the largest possible total area? I got the dimensions. So to maximize the area, I just multiply, right? Length times width. So 75 feet times 187.5 feet comes out to be 14,062.5 square feet. So that's my final answer. Okay, now the problem's actually done, but I do want you to notice what the power of the calculus is able to help you. Yeah. How would you figure this out without calculus? There's really no way, right? What are you going to do? Guess? Okay. And some of you may have thought, oh, I know, a lot of these end up being a square. No, it's not a square this time. The ideal shape is not a square. The ideal shape is 75 by whatever, 187.5. So that will maximize the area here. Okay, so calculus is a tool that lets us answer this question, which otherwise you wouldn't know what to do. You'd just be guessing blindly. And if you guess blindly, you're probably going to guess wrong, right? Okay, so that is that one. And let me, that's all I have on this sheet of paper again. So let me do my focusing thing on that. I do have another problem on this paper. I'll come back to it if I have time. It's a curve sketching problem. Okay, so that's it for that one. Okay, next one I want to try for you is 25. Find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius r. Dimensions of the rectangle of largest area that can be inscribed in a circle of radius r. Okay. So how do I do that? All right, so here's my picture. Circle of radius r is x squared plus y squared equals r squared. Okay. I have a rectangle inside here. How do I arrange the rectangle so I get the maximum area? Okay, temporarily ignore this radical 2 over 2 r stuff in blue. That turns out to be the final answer, but we don't know that yet. Okay, so the equation of a circle of radius r, again, is x squared plus y squared equals r squared. Okay, so I call this x, I'll call this y. After all, that's how we normally label a point in the, let's say, the first quadrant. X is how far do I go this way, Y is how far I go this way, right? So what's the area of this rectangle? Well, if this is X, then as a distance, this is also X. So this length is 2X. Likewise, if this vertical distance is Y, by symmetry, this is also Y, so 2Y. So the area of this rectangle is 2X times 2Y, or 4XY. All right, now, X squared plus Y squared equals R squared. Do a little bit of algebra. That gives you Y equals the square root of R squared minus X squared. And I trust you can figure that out. All right, solve for R. Subtract the X squared, then take the square root. So I put that over here. So A of X is 4X, radical R squared minus X squared. Okay, and X is going between 0 and R. Okay, you can't be any smaller than 0. You can't get past the R either, which makes sense. So I'm actually trying to maximize and or minimize a quantity on a closed interval. So I'll be doing a closed interval method, for which you had that quiz a couple of weeks ago, right? And it's pretty easy to see what happens at the two extremes. What happens when you plug in 0? Area is 0, right? What happens when you plug in R right there? R squared minus R squared, also 0. And that also makes sense. If X is 0, you're not going anywhere horizontally, so your area is 0. If X is R, it's going way out here, which means there's no height, so you also have a 0. Okay. So I'll just set A prime equal to 0, and that'll be my critical number. In fact, that will automatically be the maximum. I don't even need to do the second derivative, for which you're probably happy because it's going to be a big mess. So this becomes a maximizing or minimizing a quantity on a closed interval, right? And you did that for an in-class assignment a while back. A quiz, but this is way back in section 1, closed interval method, right? Page 281. Right. So find the critical numbers, find the endpoints. And that led to, oh, what were those problems? This stuff on 284, right? 47 and on. You find the absolute maximum minimum on a closed interval. And remember we said we had to check the endpoints. I've already done the 2 endpoints. We know the area is 0. Okay, we're going between 0 and R. I plug in 0, you get 0. Plug in R, you get 0. So the maximum must be at the critical point. Okay, so to differentiate this, though, is a little bit of a bear. I have underlined in red, first function, second function. Remember, that's R squared minus X squared to the 1/2 power. Even though you see 2 letters here, R is considered constant. Okay, the only real variable is X. R is constant. Okay, so first function for X times the derivative of the second. So the derivative of this is 1/2. Remember, it's blah, blah, blah to the 1/2. 1/2 R squared minus X squared to the -1/2. And then by the chain root times the derivative of the inside with respect to X, that's -2X. Okay, remember, R squared is 0. The derivative is 0. It's considered constant. Okay, and what am I crossing off? In red, that X cancels, that 2 cancels that 2. Okay, plus second function, radical R squared minus X squared, times the derivative of the first, which is 4. Okay, so now trying to clean that up. So I left that one alone. What do I have here? The 2 cancels that 2. I have 4X and another X and a negative sign and a square root in the bottom. Okay, take inventory again. That 2 cancels that 2. I got a negative. I have 4 times X, 4X squared. And then R squared minus X squared to the -1/2 is that. So I think we're good. It looks like it's going to be messy, but it's actually not so bad. Move this over, so I get positives, right? See that negative? Add it over. I can cancel the 4s, right? Divide both sides by 4, it's gone. and then multiply both sides by r radical r squared minus x squared. That's going to be nice here because it just cancels out. That's going to be nice here because you have a square root of r squared minus x squared and another square root of r squared minus x squared, which is just r squared minus x squared. So r squared minus x squared equals x squared. Move over the x squared. R squared equals 2x squared. Divide by 2. X squared equals r squared over 2. Take the square root. So x is r over radical 2. That's only x. It asks for the dimensions all the way across, so I double it. Okay. So that would be 2 over radical 2. And by the way, y, yeah, let me plug in for y. Y was square root of r squared minus x squared. So r squared minus x squared, we saw was r squared over 2. So what's r squared minus r squared over 2? It's also r squared over 2. Okay, you can get a common denominator here. I'll let you figure that out. So that's essentially r over radical 2. That means x and y are equal. So yes, as you might have guessed, this should also be a square. So both x and y are r over radical 2, but it asks for the dimensions of the rectangle. So for the dimensions, I double x and double y. So they're both 2 over radical 2r, but 2 over radical 2 is more commonly written as just radical 2. So radical 2r by radical 2r, those are the dimensions, which does indeed give us a square. Okay. All right, so that's 25. I'll do my focus thing on that one also. Okay, that's all that. And let's see, everything else on this paper I've already shown you. Yeah. Okay, then one more applied problem to show you. It's a little bit harder. 37, the last one. I'll get that for you. Okay, 37. A piece of wire 10 meters long is cut into 2 pieces. One piece is bent into a square and the other is bent into an equilateral triangle. How should the wire be cut so that the total area enclosed is a maximum or a minimum? Okay, and by the rules of the game, I'm going to allow for the possibility that the entire wire is used for the triangle, and also the other extreme where the entire wire is used for a square. Okay, so what are they talking about here? Okay, so here's the entire wire, length of 10. I forgot what was the unit. Was it meters? Meters. All right, make a cut. So one side's x, the other is 10 minus x. You bend one of them into the shape of a square. You bend the other one in the shape of an equilateral triangle. How do you make the cut to maximize and minimize the quantity? So this is another maximization or minimization on a closed interval. And again, we're allowing for the possibility that the whole thing is a square and also the whole thing is a triangle. All right. So first, I think most of you are much more comfortable with squares and equilateral triangles. So I took the harder expression, 10 minus x, to figure out the square. So if I bend this into a square, each side is 10 minus x over 4. Agreed? Okay. This much, this piece right here is all for square. So I bend it into 4. That means I take 10 minus x and divide it by 4. This piece, x, I divide it into an equilateral triangle. So each side will be x over 3. Right? Now I could do it the other way. I can make this x over 4, and this would be 10 minus x over 3, but we're less comfortable with an equilateral triangle, so I decided to make this one the easier one, let this one be the harder one. Okay, so for this one, before going on, we have to figure out, take a little time out, what's the area of an equilateral triangle with one side being S, let's say. Okay, so this is our timeout below this line here. How do I find the area of an equilateral triangle? So I called all of these S. I dropped a perpendicular here, which means this would be 1/2 S. And then Pythagorean theorem, h squared plus 1/2 S squared is equal to S squared, right? Using this right triangle right here. All right, 1/2 S squared is 1/4 S squared equals S squared. Subtract 1/4 S squared. 4 over 4 is the coefficient of S squared, right? It's 1. 4 over 4 S squared minus 1/4 S squared is 3/4 S squared. Take the square root of both sides. Don't need plus or minus, these are distances. So H is the square root of 3/4 S squared. Square root of 3 can't do anything. Square root of S squared is S. Square root of 4 is 2. So formula for the area of a triangle is 1/2 base times height. So 1/2 S times the height, which I now found to be S radical 3 over 2. 1/2 base times height. So S squared radical 3 over 4 is my answer for the area of an equilateral triangle. Okay, so you can put that in your next cheat sheet if you want. So if you have an equilateral triangle, one side is S. Here's the formula for the area of an equilateral triangle. It has to be equilateral. If it's not an equilateral triangle, don't use this formula. S squared radical 3 over 4. All right, so finally, I'm ready to write a weird expression for the area of the sum, total area. Okay, now we know how to find the area of a square, right? It's the length of the side squared. So I square 10 minus x over 4. So A of x is 10 minus x over 4 squared. I put a little square there to indicate that's the area of the square. And now with this new formula for the area of an equilateral triangle, we now know one side is x over 3. So here it is, x over 3 squared, radical 3 over 4. So this is for the square, this is for the triangle. All right, so cleaning this up, I have 1/16, right? 4 squared is 16 on the bottom. 1/16, 10 minus x squared plus, okay, what did I do here? X squared over 9 times 4, 36. So 1/16, 10 minus x squared plus x squared radical 3 over 36, x going from 0 to 10. So again, just like the previous problem, I'm maximizing or minimizing on a closed interval. In fact, this time they want you to find both, maximum and minimum. Okay, so that means I definitely have to plug in 0, and I definitely have to plug in 10, we said. So I need A of 0. What happens when I plug in 0? Okay, so A of 0, put a 0 here. That means none of it is a triangle. It's all square. So that's the extreme where everything's a square. So put a 0 here, put a 0 here, that's gone. Put a 0 here, you have 10 over 4 squared. It's 100 divided by 16, 25 divided by 4, 6.25. So again, all square, the area is 6.25. How about A of 10? If I put 10 here and here, notice what happens when you plug in 10 right here. 10 minus 10 is 0. So there's no contribution for the square. It's all triangle. So the other extreme is all triangle. Right, so I put in 10 right here. 10 squared radical 3 over 36. That's 100 over 36. 100 over 36 reduces to 25 over 9. So 25 radical 3 over 9, it's about 4.81. Okay, that's if it's all triangle. Again, ground rules, give exact answer whenever possible. Exact answer means leave ln as ln, leave e as e, leave square root as square root. Okay, just like on the quiz. Okay, so you should give me the exact answer. E to the -1 or e to the -2. Don't give me a decimal approximation unless you need to know what it is approximately. Of course, here I need to know what it is approximately, otherwise I can tell which is bigger. So this is about 4.81. Okay, so if I make it all square, 6.25. If I make it all triangle, 4.81, so it's less. And finally, I need to know any critical numbers. Okay, so I just take the derivative of this mess. Okay, so 2 comes down, hits the 16, that's 1/8. 10 minus x to the 1, then by the chain rule times -1. Right, the derivative inside is -1. Plus derivative of this, 2 comes down, cancels to 36, x radical 3 over 18. And I set that equal to 0. And by the way, I played the trick here. Apply -1 to 10 minus x. If you apply -1 to 10 minus x, you get x minus 10. Plus x radical 3 over 18. That's a big mess. I don't like the fractions. So I multiply both sides by 72, common denominator, just to make it look a little nicer. Right? All right, so distribute 9 times x minus 10 plus 72 divided by 18 is 4. 4x radical 3 equals 0. Distribute 9x minus 90 plus 4x radical 3. Add 90 and factor out the x. 9 plus 4 radical 3. Divide by 9 plus 4 radical 3. Here we go. And we get about 5.65. And what's the area at 5.65? So I have to take 5.65 and plug it back in here. It's messy. Okay. 5.65 there, 5.65 there. Just take my word for it, it's about 2.72. All right, so I have my list. My areas for the critical points and the endpoints are 2.72, 6.25, and 4.81. So this is the biggest number, all square, and this is the smallest number. Okay. So finally, the maximum occurs at x equals 0, where the area is 6.25 square meters. The whole thing is a square. It's all square. The minimum is to cut it at x equals 5.65. That means I cut here where this is 5.65, bend this thing into a square, bend this thing into an equilateral triangle, and that area comes out to be 2.72 square meters. Okay. And you can see, without the techniques of calculus, how would you know how to do this, right? It's pretty nigh, almost impossible to think, how would you work this out? Okay, so that is it for this one. I do know some of you put something in the chat. Let me get that. Just a second, let me show you this quickly here. The focusing thing. Okay. All right, so that was about all I was going to do for the word problem section. Let me check. Some people just came in late. Yeah, okay. So that's fine. All right, so what time is it? I think I have time to get started with a back question on a curve stretch. So I am done with 4.7. I think I can go ahead and mark this off. And I've already done a whole bunch of these problems. So you know how we say on exams, you have to do at least 70% of the homework, right? That's almost a joke because I do a great percentage of the homework. Sometimes I end up doing 70% or more of the homework anyway, in which case all you got to do is just copy what I did, right? Okay, so starting tomorrow, I'll do 4.8. So we're good to go on schedule. But again, we're not going to have to test this week. We're going to postpone it until the 30th, which means I will get started though with 4.9, 5.1, and so on. So again, Friday, I'm heavily leaning toward giving you another quiz, which is a little bit harder maybe. It's an applied max-min problem. So the quiz that you had last Friday, again, it's not likely I'm going to make you do the whole thing on a test. So I figured, okay, I'll make you do the whole thing on a quiz, because otherwise you'll never get a chance to do one of these problems from start to finish and have it count towards something, right? All right, so I was asked about one curve sketch way back in 4.525. So let me see if I can at least get started with that in the remaining time we have. And then tomorrow we'll get started with 4.8, hopefully. So 4.525, one curve sketch. Okay, y equals x over square root of x squared plus 1, which of course, as you know, is not very nice because of the square root. Well, let's see what we can do with it. All right, domain is all real numbers. You say, isn't there a square root? Yes. Isn't there a fraction? Yes. So I have to say, oh, I can't let the denominator be 0, but take a look. The denominator is always positive, isn't it? X squared plus 1 has to be positive. Square root is always positive, so all real numbers. Intercept, origin. Plug in 0 for x, you get y. Plug in 0 for y, has to be x. So it touches the origin. Symmetry, f of negative x is negative x over the square root of negative x squared plus 1. But negative x squared is the same as x squared. So again, negative x over radical x squared plus 1, that is the opposite of the original, negative f of x. So that means I have an odd function, or I'll have origin symmetry. Of origin symmetry. Now, limit as x approaches infinity. That's going to be tough. Okay, it is infinity over infinity. You might want to try L'Hopital's rule, but it doesn't really help. Okay, the derivative of the bottom is going to be a mess. So here's a case where even though L'Hopital's rule applies, if I plug in a super big number, the top is big, the bottom is big, but you don't really want to take the derivative of the bottom. So the only good way to find the limit of this one as x approaches infinity is a trick that we did a while back. It's to go like this, right? X over radical x squared plus 1, divide top and bottom in red by x in a certain fashion. Divided by x outside is the same as dividing by x squared inside. So that gives me limit x approaches infinity of 1 over radical 1 plus 1 over x squared. And now when x gets super big, right, that gives me 1 over radical 1, which is 1. So I have y equals 1 is a horizontal asymptote. And therefore, by symmetry, y equals negative 1 is also a horizontal asymptote. So when I go way out there, I approach 1. And since I know I have an odd function, I have symmetry with respect to origin, way out here, I approach y equals negative 1. Okay. Or you could say limit x approaches negative infinity and just do the exact same analysis here, and you'll get the limit to be negative 1. Okay, y prime doesn't look like it's going to be that nice, but actually it is, believe it or not. Okay, so how do I differentiate this? So bottom times the derivative of the top, right? What's the derivative of the top? 1. So radical x squared plus 1. Now the hard part, top times the derivative of the bottom, minus x times the derivative of the bottom. The bottom is x squared plus 1 to that 1/2 power. So x, 1/2, x squared plus 1 to the negative 1/2, then by the chain rule times the derivative of this, which is 2x. All over the square of the denominator. That's nice. What is the bottom squared? X squared plus 1. Okay, now I got to try to clean up this mess, but believe it or not, it actually comes out nice. Okay, so temporarily ignore the red. There's radical x squared plus 1. Let's see, that 2 will cancel that 2. I have x times x, which is x squared on top, and radical x squared plus 1 on the bottom right here. all within the numerator of the main fraction. Okay, so right now I have all of this. Ignore the red temporarily. But look at what happens if I multiply top and bottom by radical x squared plus 1. Comes out very nice. Because that times that is just x squared plus 1, right? That times that cancels out, so you just have x squared. So if x squared plus 1 minus x squared, the bottom becomes x squared plus 1 to the 3/2 power. This is x squared plus 1 to the 1 power. This is the same thing to the 1/2 power. 1 plus a half is 3/2. And look what happens. X squared cancels out. 1 over x squared plus 1 to the 3/2, which is greater than 0 for all x. F is increasing from negative infinity to infinity, decreasing nowhere, therefore no max or min. Okay. Always going up. Okay, and I'm about to do the second derivative, but before I do the second derivative, rewrite this expression as x squared plus 1 to the negative 3/2. Right? Again, avoid quotient rule if you have a constant either on the top or bottom. So I'm going to differentiate x squared plus 1 to negative 3/2. So y double prime is negative 3/2, x squared plus 1 to the negative 5/2. Then by the chain rule times 2x. Again, the 2 cancels the 2. Negative 3x over x squared plus 1 to the 5/2. Set that equal to 0. When is a fraction equal to 0? When the top is 0. Again, a over b equals 0 means a equals 0. That's easy. What makes the top 0? 0. So x equals 0. I already had that point. It was the origin. Right, so sine chart. It's a pretty easy sine chart. Plug down 0. The bottom's always positive. Just look over here. If I plug in a negative number, I have negative 3 times a negative, it's positive. Plug in a positive number like 1. Negative 3 times 1 is negative 3. We already know that's positive. Negative. Second derivative positive, concave up. Second derivative negative, concave down. So f is concave up from negative infinity to 0, concave down from 0 to infinity, inflection point the origin. And here's the entire graph. So there we go. Horizontal asymptote, horizontal asymptote. Domain is all real numbers, always increasing. First concave up and then concave down. And there we go. So let me just do my focus thing on this and then we're out of time. Okay, so I'll show you this, but tomorrow we'll get started on our last section, something called Newton's method of approximation. Okay, and I will very likely get started with the next chapter, which to me really counts 4.9. Okay, but again, 4.9 is not on this test, it'll be on our final test. I think it really belongs in chapter 5, in my opinion. All right, so there we go. All right, so we're out of time, folks. So we'll continue tomorrow. All right, see you, everybody. Have a good day.